Hello, my name is Luis Avalos, and today I will show you how to make a home automation project using an LDR photosensor, like this. But first, it is necessary to understand how the electrical circuit works. First, we will have a 5-volt power source, like this. Afterwards, we will have a 1 kilo ohm resistance. Then, connected in parallel, we will have both a light emitting diode, like this, and a photoresistor. Which will be connected to ground. Alright, then we also need to understand this chart right here. When the input is 1, that is, when the light intensity increases in the photoresistor, then the output will be 0. That is, the light emission diode will not turn on. Then how we understand this is that when there is there's some light being captured by the photoresistor, then the resistance will decrease in such a way that the current will flow in this manner. As we can see, when there is an input, that means when the light intensity increases, there will be no current flowing through the light emission diode, which means, of course, that there will be an output of 0. Now, in the contrary, when there's an input of 0, that means when the light intensity decreases, the resistance will increase in such a way that the current will flow in this manner. Now, the current will flow through the light emission diode all the way to ground and closing the cycle. Now, when it comes to the materials that we will need for the electrical circuit, it will be the following. First, we will use 5 jumper wires as well as a 9-volt power source. Then, we will employ a Arduino Uno as well as a photoresistor, a green LED, as well as a 1 kilo ohm resistance, and finally a breadboard. First of all, we will need to connect a jumper wire to the 5-volt mark in the Arduino Uno over here. And then we will connect it to positive on our breadboard. Afterwards, we will connect using another jumper wire, ground to ground. Then we will connect our 1 kilo ohm resistance to the power source, and we will connect it anywhere in our breadboard. Now, as we mentioned in our electrical diagram, after the resistance, both the light emission diode and the photoresistor will be connected in parallel. In order to achieve that, we will have to use 2 jumper wires. But first, we need to remember that in an LED, the shorter one is the cathode, which is negative, and the longer one is the anode, which is the positive one. That means that we need to connect the cathode to ground. Then, we will connect the photoresistor to the resistance and to ground. And finally, we can connect the battery to the Arduino Uno. And as we can see, the LED lights on. Now, if I use my phone to turn on the flashlight, as we can expect, once I give an input to the system, that is to the photoresistor, then the input will be 1, So the output has to be 0, which means that the LED has to turn off. Of course, this happens because by giving an input to the photoresistor, the resistance decreases, and of course, the current now will flow through the photoresistor instead of the LED. As we can see, if there's an input, then the output is 0. And if the input is 0, then the output will be 1, which can be expressed as the LED lighting on. Personally, I really like this project because it was such a nice way to get into the world of electrical circuits, and I also believe that it was really nice because it allowed me to understand the importance of automated electrical circuits or automated electromechanical systems with which we interact in our daily lives, even though we don't realize very often. Thank you.